Hello friends, we are back with a new video. This time a vegetable, and that is an old vegetable, that is cucumber. Now what has happened with this cucumber is that uh, it is been overhydrated. That is, lots of water has been poured over it to keep it fresh, and due to this overhydration it has got petrified. So this is very dangerous. So if you think some thing looks fresh, but you should watch it. If it is soft looking in appearance, if it is soft, if you touch it and you find it is soft, then it is overhydrated. So we have to avoid those type of vegetables, because those type of vegetables are not good for health. They may already have caught the fungus, and those fungus may not be good for us. So here is a cucumber in front of in my table, on my table, and it is, you can see that it is has been wrapped in a tissue paper. You will be looking for it to get a laparoscopic view. To just We will be cutting it and we will be opening it, and inside and going inside to see what has happened, how much it has got petrified, whether it has acquired any fungus or not. If we see it has occurred any fungus or something, we will be putting in the agriculture media, that we will be doing in the latter part of the video. So first of all, we will be unwrap this cucumber, and we will see through laparoscope that what has acquired it inside. So now in the next part of the video, we will see that under laparoscope, we will be unrevealing the condition of this cucumber, and what has happened in it. So please be with me with this video to see the more actions of this cucumber. It may be a cucarata fungus, or it may be a new one, or it may be just a petrified view of this cucumber that we will see under laparoscope. So be with us. So you can see the dissection is, this is the laparoscopic view of this cucumber, overhydrated cucumber. You can see the petrification, and in the right hand side corner you can see the petrification. Now you are using a forceps to turn the cucumber, and you can see the petrification, right? The color has changed. The petrification has already started and the color has changed. Now we are going to resect this fungus. First you have to dissect the dissection has also started, and we will first dissect the cucumber, and then we will go inside and we will find out take some samples, excavate some samples from the cucumber. So that dissection is going on, and you can see the cucumber is petrified, and we are trying to dissect some of the specimen from the cucumber. We are just on the other sides, that is a scalpel. On the four sides we are dissecting and making a square, and we are dissecting the area of petrified thing. This is due to the overhydration, and just we are now changing the instrument, and we are now taking the forceps to resect the fungus. That is the forceps introduced, and we are just opening up the dissected part. Now we are going to resect the tissues, the part of the cucumber. Now we are resecting, and that is a blunt dissection. We are just going to resect that thing, and the section is going on. So now we have entered inside. Now we will be taking some of the part of the. You can see the water is oozing out. You can see the water is oozing out. So it is supposed to be dry cucumber. Almost the cucumber is dry, but inside is full of water. So water is oozing out, and you can see the very soft cucumber tissues inside. So this is the condition after due to overhydration of the cucumber. So this we have done, and it has been collected in the culture flask. So they are getting collected in the culture flask. So we are resecting the tissues from the end, and we are dissecting. The dissection is going on. You can see this is the white spongy thing. It can be jelly bulbous, but that we will decide after seeing the culture media. At present the fungus is not visible. At present it is visible that it is overhydrated. So let us see what the culture media shows us. after 15 days. So now the laparoscopic resection is going on. So we are just resecting and taking up more and more samples so that we can go deep inside. We are trying to penetrate deep inside, and we are collecting the tissues. So that is again we are pressing the sample. This is a very slow process. It takes a long time. With the help of the laparoscope we can see it and take a better photograph. Try to show you the better photograph. But this is the very slow process. So we are just resecting and the resection is going on. So almost the resection is towards the end. So we are just taking the tissues, samples of different kinds of tissues we are finding here. The layers of the tissues is been resected. So that is the process. So that is going on. So almost the reaction is end, coming to an end. So this is done. So as you can see, the resection has been done and it is there in the flask. So it is there in the flask, and we just now we are not able to see any fungus occupied. The macroscopically it is, or the rather laparoscopically it is not visible. The fungus is not there. So we are just seeing the cucumber. It is overhydrated now. In the laparoscope you can see it is overhydrated. We have shown already in the laparoscope. The water was oozing out from the dry, almost semi-dry cucumber. The water was protruding out, oozing out actually. So this means that it is overhydrated. This cucumber was overhydrated, and we have collected some of the parts in these pieces in these, resected some of the pieces in this flask, in this collection flask. Now we are going to put a sodium acetate differential agar to just to see what fungus it is. So just we will be doing that. We will take around 6 ml to 10 ml of sodium acetate differential agar, and we will be putting it into the culture flask. So already we can see the specimen is in the culture flask. The resected specimen is in the culture flask. So we are now going to put this in the sodium acetate differential agar. The initial color of the sodium differential agar is green. So let us see what happens when it goes inside goes and reacts with this fungus. So more is needed. So this is 5 ml. So we are going to take around 10 ml. So let us see what it does, and little bit more. So another 2 ml we will be done. We will be enough. So this is enough. So now it is in the culture media, and the excavation and the extraction is done. So we will be seeing it after 10 days. Around 10 days we have to keep, because normally the fungus is not visible. So we have to keep it for 10 days, because to make the fungus more visible, now the fungus is not yet visible. So to make it more visible, we have to keep it for 10 days, long period. We have to give a long period. Now 5 days, 5 days, 5 days we have to give. So then only we will able to see whether the fungus is protruding out or not, because this overhydration generally causes it attracts the fungus. So we have to see whether the fungus is acquired or not, to see that, because this is maybe this is a very slow progressive fungus. So sometimes the progression of the fungus does not mean that it will be very fast. So generally some of the fungus is progressive. They are very high progressive fungus, or rather the fast progressive fungus, and some funguses are very slow progressive fungus, or low progressive fungus. So that we'll see after 10 days. So we have to give the 10 days, because we cannot see macroscopically this fungus is not visible. We are only seeing the oozing of water is coming out. When in the laparoscope we saw that some water was oozing out. So it may not contain as visually it is not seeing that fungus is there. So we are just we have to wait and watch and see whether the fungus is acquired or not. So this we have to keep for 10 days in the incubator to see whether the fungus is acquired or not. Now the sodium acetate differential agar is a very intelligent agar. It generally reacts with the fungus, and it pulls out the fungus from the surface or the something, the host, it actually pulls out the fungus. So therefore we have used the sodium acetate differential agar. Now let us see if we put it in the culture medium, what happens. So that will be our future part of this video. So be with us. Hello friends, so we are back with this cucumber, overhydrated cucumber, and it was in the sodium acetate differential lager, and now we are back after 3 days, almost 3 days. So because the, as you can see in the flask, the fungus has a very rapid growth. So as I have said earlier, that some funguses have a very rapid growth, they have a very fast and rapid growth. So that's why we have returned within 3 days. So and you can see the culture media in the camera, you can see the culture media has also become very thick enough. So it can be, as suspected, it can be of 4 types of fungus, it can be 4 kinds of fungus. One, it can be a ceffela perivelus, it can be Arabella raffinus, or it can be alum perivelum, or it can be ceffela negros. So these are very rapidly growing fungus. This is the ceffela group or Aralia group. The ceffela group is very fast growing fungus, and the Aralia group is also very fast growing fungus. So let us see which fungus it is. So we are going to first we are going to morcellate this fungus, the medium, the culture media, the whole total microbiological media, biological media. We are going to morcellate it. Then we will see what happens. So after morcellation, as you can see, this is a very thick enough growth. So after morcellation, we are going to dilute this thick enough media. So for that, we are going to use a physiological dextrose saline. Let me see what can be done after that. So let us first morcellate it, the whole media. We are going to morcellate the whole media. Then we will be able to see what fungus it is. We need to morcellate it because this is a very thick media. If we directly see it and try to see it under this important microscope, we won't be able to see any proper structure of this fungus. So we are using a morcellator. We are using a 30 ml morcellator. This is a 30 ml morcellator, glass morcellator. Now we are going to put this fungus into this morcellation. Total morcellation is a thick mass, you can see. So we have to morcellate it for about a minute or two. So therefore we will be able to see what is inside. Then we need to dilute it. As you can see in the camera, in this side camera, in this bigger picture, that this morcellation is going on and the medium is getting lacerated. So we need to lacerate it. This laceration sometimes destroys the morphology of the fungus, but nothing doing. We have to morcellate it because this is a very big fungus. You can see the laceration is going on and the tissue morcellation is going on, but it is very cute fungus. It's a very big mold. It has become a very big mold, rapid growth. So already we have morcellated it, and now we are going to put back. Just, this is a very sharp morcellator. So we are just going to morcellate it just few more times. We are going to morcellate it. As you can see in this camera also, the morcellation is almost done. The upper part has become volatile light. It has become fully liquid, homogeneous, actually fully homogeneous. So now we are going to put this back to the culture flask, initial culture flask, and from there we are going to take back some of the culture media, and then we are going to dilute this media because this is a very thickened part. So we need to dilute it. So what we are going to do, we are going to take this time around 1.8 ml of the culture media, or 1.8 of this microbiological media, just making it, and we will be taking this culture media 1.8 ml, and we are going to dilute it, or rather we need to make it little bit light this media. We are going to make it little bit light. So we are going to use around 1 ml of this physiological dextrosaline to solution. Physiological dextrosaline. This is a physiological dextrosaline. Just we will mix 1 ml of this physiological dextrosaline to make it little bit light. As you can see in the camera that this mobile medium now has become light, so the dark density has gone. So therefore we will be able to visualize the morphology of this fungus very well. So this anyhow we will discard. This will not take back to the culture media. We will just discard this. We will just discard this. Just after viewing, we will discard this. Don't put back into the culture media return back to the culture media, because this we have to discard because this is already dilutant. This is a dilutant. This is 1 ml dilutant. We have used 1.8 ml of the culture media and we have given 1 ml. So more than 10% we have used to dilute it. So this won't do. This will stop the growth inside this original culture media. This will stop the growth because saline will stop the growth. So you never put this back to the culture media. We are just going to watch this morphology to make that. For that we are making this medium dilute. So never use this back to the culture media. So now we are going to investigate under TCM 400 microscope what fungus is this. Within this 4 group, the ceffela perivelus or Aralia raffinus or Alum perivelum or ceffela negros that we are going to see. So now we are going to the microscope and see this, what is the structure. So be with us. So as you can see, this is ceffela perivelus. This is a very big fungus and a very fast growing fungus, as it has emerged within 3 days. So this is lacerated form. This fungus has got lacerated due to morcellation, but you can see even the neonatal cells are also visible. This is a very thick culture media, so it is very difficult to focus. But anyhow, it is focusing. But now you can see a small ceffela fungus. So this is ceffela perivelus. So you are just showing different parts of the specimen, different portions of the specimen. So this has been diluted, as you can see, as you have seen, it has been diluted in physiological physiological dextrosaline. So after that also the proportion is also very thick, so it is very difficult to focus. Anyhow, the cephalas are floating. So this is a cephela fungus again, and this is what we are looking for. So this is ceffela fungus. So more parts are there, more parts are visible. This is already 200x magnification. You can see this is another ceffela colony. We are trying to focusing it, but it is very difficult to focus. Now it is little bit hazy here because the colony is very deep. So little bit it is getting focused now. You can see the inside parts. This is the ceffela colony. It's a big ceffela colony. So we are watching different things, but the main fungus is ceffela fungus, ceffela perivelus. So this is a very rapid growing fungus and it becomes very thick. So you can see some bacteria are also there, some gram positive bacteria are also there, but the main fungus is ceffela perivelus. So the light is getting adjusted, so you can see this is ceffela perivelus. So nothing much more to see. Now this is another very big ceffela colony. We are trying to focus it to see how much it has become big. So it is very big now. It is very big and very thick colony. So inside structure is not visible, but first you have saw the structure. So these are the other parts of the specimen. This is mainly cephela is there. So this is cephela fungus. So this is ceffela perivelus under TCM 400 microscope. This is a very fast growing fungus. Within 3 days it has grown up. we have enough grown up so that we have to dilute it with dextrose solution. So this is ceffela perivelus. As is that much you can see. So friends, we are again back after another 2 days with this same fungus. We are just observing this fungus under from the incubator microscopically, and you can see it has become a profuse, now it has become a profuse medium. But unfortunately the color of the sodium acetate differential agar has not changed yet, but the fungus has given us a very profuse growth. So after morcellation, it is still there. It is growing very vigorously. So now we are going to examine a second make a second. We have planned to make a second examination under my TCM 400 microscope. Now this time we are going to dilute it 50%. So 50 is to 50, 1 is to 1 dilution we are going to do. This 1 is to 1 dilution is that we are going to take 1 ml of this content and we are going to mix 1 ml of this physiological dextrose saline. As you can see here, the physiological dextrose saline. So this we are going to mix 1 ml of that. So after that we are going to visualize under TCM 400 microscope. Now this fungus is growing very fast, very fast. Within 4 days it has grown over almost 200%. So this is a very fast growing fungus. Therefore we have planned to see the more growth or more growth approach of this fungus. So now we are going to see it under TCM 400 microscope after this dilution. So now we are going to dilute this. We are going to take the fungus, say around 1 ml of this fungus we are going to take, and we are going to mix with physiological dextrose saline another 1 ml. So now, and see what this fungus growth gives. It's a very vigorously growing fungus. So we are just going to take this fungus, it's around 1 ml, not more than that, because it is a very constricted construct. It is a very deep fungus with a very thick fungus. So we are going to put this fungus and we are going to give around 1 ml of physiological dextrose saline, and to see what growth it gives us, or rather how much growth it has done, and what is the structure of the fungus. So that we are going to study. We are just going to mix this physiological dextrose saline, and this saline just actually removes the color or decolorizes the culture media. It actually decolorizes the culture media. So here in the case, it decolorizes the culture media. So therefore it becomes easy for the microscope to visualize through the culture media. It has decolorized the culture media. As you can see, the fungus has grown over in it, and we're just going to see this. So this is the advantage of this physiological dextrose saline, that it decolorizes the culture media, because due to sometimes it is a thick culture media, sometimes it becomes very difficult to visualize through the petri dish, glass of the petri dish. The light penetrates to the bottom of the glass of the petri dish, and goes up to the objective, goes up to the eyepiece, and the objective is down beneath, and the light is coming from the top, and it is going bottom, and it's going through the petri dish and going to the objective. So a thick glass comes in between, and thereafter, if the culture medium is very thick, then it will be very difficult to visualize for the microscope. So therefore now we have just diluted and we have decolorized the culture media. Almost we have decolorized the culture media. Now we are going to visualize this under TCM 400 microscope and see if the morphology is better than before. So if the morphology is better than before, then we are going to see it under fluorescence. Then we will be able to see under fluorescence. So let us see what gives after. So this is the second investigation of the cephalum perivelus. Now what we have done, as I have told, that we have just diluted 1:1 by the dextrose agar. Now you can see the cell very better. So now the microphone, we are just moving the positions. So this is a stabulum. We are now focusing the stabulum, and you can see the clear structure of the stabulum, almost very clear structure of the stabulum. Now this is because we have decolorized the culture media. The culture media, the color of the culture media was affecting the light of the microscope. So therefore we have decolorized the culture media with the dextrose saline agar, and we have now seeing the in different pathological structures of the microbiological structures of the cephalum perivelus. So these are staphyliums. Also some nuggets or parasites is developed. Small parasites is also developed, but that is not very important. Those are not very important, but main fungus we have identified, that is cephalum perivelus. So this which we are visualizing now, this is the second examination after dilution. This is a very big colony of perivelus. There is a very big and thick colony of perivelus, so we cannot penetrate through. Now just we are focusing the microscope and the phase contrast view of the perivelum. You can see perivelus, you can see this is a perivelum colony. So another perivelum colony, lots of perivelum colonies is developed now after 7 days actually. This is almost after 7 days. So this is the 7th day actually. So this is a staphylium ring. You can see in the front of it is a staphylium ring. So more structures are there. So more and more structures are coming. So these are staphyliums. Again a fringe of the colony. This is also a perivelus colony. We are trying to focus it. It is hanging in between. Now it has been focused almost. You can see inside the structure. So this is a perivelum colony. So this is a perivelum colony. It is almost focused, and it is a perivelum colony. So these are the other parts. This is a very big, another very big perivelum colony. You can see inside the patches, the fringes and all that. It has spread over. So this is a perivelum colony. The more perivelums are there, more perivelum structures are there. They are floating actually. So these are staphyliums. So we are focusing the staphyliums. So they are nicely focused. The staphyliums are very easily visible because they are transparent. Almost they are transparent. So inside structure is visible. So that is a perivelum network web, perivelum web actually. So visualizing the perivelum web. This is a perivelum web. You can see a perivelum web. So this is a perivelum web. You can see. So this is a very big colony. You can see this is a very big colony. It's almost taken over the screen. This is 200x magnification. We want to see the 5 fringes or stylets coming out, protruding out. The stylets are protruding out, but it is not visible. So we are decreasing the magnification. Now it is 100x magnification. Now you can see the stylets. You can see the stylets 100x magnification. You can see the fringes of the stylets. So these will be visible, very good visible, very well visible, will be visible under fluorescence. So that will be done after the next part of this video. So these are the stylets. So this is a very beautiful colony. It's like a mattress. It's a perivelum mattress. It's a layer of perivelum. This is the layer. This is a broken layer or lacerated layer after morcellation. So this happens. You can see the edges. They are lacerated. So this happens after morcellation. So very big tissue which has already, I have told you, it has covered the screen of the microscope. So that happens. So that's why we have to morcellate the tissue to bring it down. So these are all stylets, staphylates. This is a small perivelum colony. It is a small perivelum colony, and almost we are end of the slide. So you can see this is Cephalum perivelus. So these are, you can see the bits of mycotoxin or pellets of mycotoxins. These are actually botrydials and also tremorgans. So this is the condition of the Cephala perivelus. So these are the darker side. So you can see more pellets of mycotoxins. This is a Cephala colony. You can see this is a Cephala cluster actually. This is a cluster fungus. These are the patches, Cephala patches. This is a small Cephala fungus, Cephala colony, and you can see it consists of tremorgans and also botrydial is present. And unfortunately, or rather you should say fortunately, or you can say rather unfortunately, the usiloxins are not present. So that is one good sign. So zearalenone is also not present, platyline is also not present. So this is actually due to overhydration. So tremorgans has arrived. Unfortunately, the botrydial is arrived. Botrydial will naturally arrive because of overhydration. So cluster fungus, and it is a cluster fungus, so botrydial will definitely come. That is due to damp and overhydration. Botrydial comes, the triglycine comes. So these are the other parts of the Cephala fungus. These are the Cephala colonies. You can see the pellets, the mycotoxin pellets are there. So these are the webs. Cephala webs are also there. So this is the actual condition of this fluorescence image. This is the botrydial chain. You can see it's a long botrydial, say short, long, very not very short, very not very long. It's a botrydial chain in the center of your screen. So this is a botrydial chain. So the pellets are forming the chain. So these are the other parts of the slide. So almost we are over. So this is a very big Cephala colony. This is a very Cephala cluster actually. It's a very big cluster. You can just focus the microscope and you can see this inside the pellets are present, inside some other mycotoxins are present. They are crystallized actually. So these are the other parts of the slide. So this is Cephala perivelus or Cephalum perivelus. So as you can see, the mycotoxin UV spectrum of the mycotoxin has arrived, and it consists of 8 mycotoxins in total, including the tremorgans and the botrydial. Also the rocoy-14 and rubrotoxin is also present. So this consists of 8 mycotoxins, and fortunately the usiloxin is not present. So this is the condition of the Cephala perivelus. This is the mycotoxin spectrum, UV spectrum of the mycotoxins of Cephala perivelus. So this is also a very dangerous fungus, as you can see.